The definition of untrusted data is an important concept to get right before we move on and start exploiting risks. And really, when I talk about untrusted data, I'm talking about something that comes from an externality. So something outside the direct control of the system, something that we have to assume might be tampered with in such a way that it attempts to do something malicious. So here's a good example, the request body. So this is what is sent to the server when a form is posted. So think about, say, a registration form. The name, the email address, the password. All of that is part of the request body. And all of that can be manipulated by the attacker. They can change any of those values. Now, not only can they change it in the web form itself, but they can also reconstruct their own HTTP request entirely independently of the browser and change these values to whatever they want them to be. That includes hidden form values too, and we're going to look at hidden field tampering in this module. Another source of untrusted data is request headers. Now, the request header has everything from the user agent, so what browser it is the user is using, to the language that they prefer, and even where they've just come from in the referrer header. All of this can be modified by an attacker. It is untrusted data. It gets sent to the system from an externality, whether that be the browser or a custom HTTP request that the attacker may have coded up, and the request headers can be set to anything that the attacker wants. It can include a malicious payload. So you cannot trust request headers. It is untrusted data. Another probably more obvious source of untrusted data is the query string. You can change a query string to whatever value you would like it to be. In the introductory module, we looked at how a query string could get a specific widget. You could change it so that it gets another widget. You could also change it so that it possibly mounts a SQL injection attack. It's untrusted data. The attacker can do whatever they want with that query string. The trick then becomes, how does the web application handle it when the query string is malicious? We also looked at routing in the introductory module. So another way of defining parameters which we might have otherwise put in a query string. Now, an attacker can modify the route because it's just a URL. So they could change that request to widget number 1 in the route, and they could change it to something like a cross-site scripting attack. Whether or not that attack is actually successful is entirely dependent on how the web application parses that untrusted data, the route in the URL. So that's another perfectly viable way of passing untrusted and potentially malicious data over to the server. Another source of untrusted data again is changing the HTTP verb. Now, I also touched on that in the introductory module. And in fact, I mentioned that in a very semantic HTTP implementation, you might support something like the delete verb in order to actually delete a resource. There's nothing to stop the attacker from changing a get verb for a specific resource to a delete verb. The question, of course, is what does the application do if an attacker is trying to delete a resource that they're not authorized to delete? That's the trick with untrusted data. You can't change the fact that attackers can manipulate untrusted data. All you can do is change how the web app responds when an attack comes in. And finally, external services. So if a web app is calling out to a service run by some external asset, the data that's returned from that service is untrusted. It could be malicious. So for example, a website makes a request to a web service on a completely different application. That application returns a malicious payload in the response, and the first application consumes that, and then possibly exposes, say, a persistent cross-site scripting attack. I'm actually going to give you an example of precisely that later on in this course, where persistent cross-site scripting attacks have been embedded into DNS records, and then the application consuming the external service and pulling in that untrusted data hasn't properly catered for the fact that it could indeed be malicious. Now, one other quick note on this as well. Defenses like SSL, so serving the content over a secure HTTPS connection, do not help one bit with this style of attack. An attacker can still quite happily modify, say, the query string of an application over an HTTPS request. That attack will still go through to the server. It's just that it will go through in a fashion that then can't be intercepted by another attacker. And then anything that the response returns also can't be intercepted. It's still an attack, it's still just as effective, and transport layer security, which we will look at in more detail later on in this course, does not provide any defenses whatsoever against these attacks. So now that we've covered that, let's move on and start taking a look at an actual parameter tampering demo.